Okay, we want to talk about projection. First projection we'll look at is a projection of a point onto a line. So if we have a line at a point, to project the point onto the line means to move in a direction perpendicular to the line until we hit the line. Okay, so this is a point called point P, and this is the projection of P onto the line L. We'll call this line L, we'll call this point P. This is how we project it. I'll give the analogy or the situation. Imagine you're out in a field someplace and an angry bull starts charging you, and you've got a fence here that you need to get over. In what direction are you going to move toward that fence? Well, it kind of depends on the direction from which the bull is charging, but if you want to get to the fence as quickly as possible, assuming you can move at the same speed in whatever direction, you're going to go straight toward the fence, which means you're going to go along a path perpendicular to that fence. You're projecting your position onto the fence, and hopefully you get over it before anything bad happens. Okay, well, that's a projection of a point on a line. And that's a very important idea. But now we want to project one vector onto another. So if we have two vectors, let's say we have this vector, which I'll call V. My chalk is disintegrating. Gee whiz. Okay, here we go. I think this will work. Okay, there's our vector V. And we want to project V onto the line L, where L, again, is just some line. Okay, how do we do that? Well, we put the vector V with its initial point on the line, and then we simply project the tip of V, the terminal point of V, onto the line. The terminal point of V is a point. We project that point onto the line, and this is the projection and I'm going to call this the vector projection of V onto line L. I haven't labeled L, but okay, here's the line L. Now, we also want to project a vector onto, looking for different color chalk here, project a vector onto another vector. So now if we have a vector V, and another vector, say W, debated about how I wanted to draw that, but I'll draw it like this. Then to project V onto W, we put the two vectors we position the two vectors with their initial points at the same point, initial point of one at the initial point of the other. And then we extend the vector onto which we're projecting into a line. So, to project V onto the vector W, we use the same initial point for both, and we extend W to line, and we might as well call that line L. So here's our line L. And now we just project V onto line L. So by projecting V onto line L, well, the terminal point of V, but we've seen how that works. We just come to line L at a perpendicular, and there we have it. Now, in this case, oh, well, of course, here's our projection now. So here's our, this is the projection of V it is onto line L, but remember, we've defined this to be the projection of V onto the vector W. We project, this is a projection of V onto W, and we denote this by the word projection with an arrow over it, because this is a vector. And then we put W as a subscript, projection onto W of the vector V. That's the rule for the projection. Now I'll simply note that if this angle is theta, that the magnitude of the projection is just the length of this side of a